I'm a senior engineer at LocalStack. Funny thing is, I just went here by foot, basically. Our office, our fancy little office is just around the corner. Thanks first to Anka and Philip for organizing and iLogix for hosting. Today I would like to talk about developing and testing serverless integrations with Elasticsearch on your local machine. Quite a title, right? But yeah, let's first start with what LocalStack actually is. I don't know if many of you heard about us. We basically develop a fully functional local AWS cloud stack, which emulates your services right on your machine. Everything is in one Docker image. You just, like, with one command, you can start all the services locally. And yeah, that's basically it. We're on GitHub, so our community edition is fully open sourced with Apache 2 license, and we're actually quite good going on GitHub. I don't know, that's the only thing to measure, right? Stars on GitHub. We're at 45K stars and 450 contributors right now. But maybe to bring that a bit into perspective, what that means, like the local emulation of the AWS services. Here's a fancy pyramid, which should showcase basically the different levels and what you can actually test of your system on those different levels. On the top, we have the classic mocking. You know that when you write a test, you basically need to mock your infrastructure. You need to tell how it should behave, and it's very, very close service tests. And then on the next level, we'd have service simulation, where you actually replace one service with an actual local version of it. The layer below is then multiple of those things and integrated with each other. Spoiler alert, that's where LocalStack is. And the last thing, or the lowest, basically is running everything in the cloud, right? To have basically the actual environment you're testing it with. And yeah, there you see the everything and can test it in a real environment, but on the other hand, it's also more tedious to do so. So just to give an example of the different levels, I don't know what you guys are working most with in terms of programming languages. LocalStack itself is implemented in Python, so this is kind of our ecosystem, and the most prominent example here for mocking of AWS services is Boto. Boto is the Moto, sorry. The name comes from Boto, which is the official AWS client for AWS. And Moto is the mocking of those AWS services. And this is like how you would write a mocked test. Yeah, when you go one level further, you go to a service simulation, and there are lots of tools available also by the cloud providers themselves, like AWS. They provide DynamoDB local, step functions local, SAM local. Same for Azure. There's Azurite and Cosmos DB emulator and stuff like that. Google also has like lots of tools to test their stuff locally, which basically is the same thing, a service emulator. And these are just stripped down versions of those real services. So DynamoDB local is basically full functional DynamoDB with some limitations. Then the key factor here is that it has a complete API compatibility. You can basically use it like the service itself. The API is completely the same. You replace the cloud with that service, and for that service it works, which is nice because when you execute stuff locally, you reduce a lot of the complexity. The running in the cloud is kind of hard. The feedback loop is quite long, so it's nice to just have a nice short feedback loop. You code a few lines, you run it, and you get instant feedback. But I mean, the good thing in the cloud is that these services are all integrated, right? You want your Kinesis stream to integrate with Firehose, which then like forwards all the data to your Elasticsearch, and that's really hard to do locally. There, you can't really test the integrations. And yeah, obviously this is where LocalStack comes in. We're basically emulating a lot of services, like more than 70 right now. And we also emulate the integration, right? So you just start it. You can see the command down here. It's just a pip package to install LocalStack. That's basically the CLI. And as soon as you run LocalStack start, it will spawn a new Docker container with the proper configuration such that it runs on your host. Our default port is 4566. So basically, it's just like that. And maybe we can just do that on the side. Okay, my terminal doesn't like overlays. Let's just jump directly to a small demo mode and just start LocalStack. That's basically it. We're ready. And this is when you can actually run your APIs, your tests against the local version of AWS, basically, against LocalStack. Okay. Obviously, we support a lot of services, the classics like Lambda and stuff, but also obviously Elasticsearch. And we'll see more about that. Basically, you know about AWS's ES service, Elasticsearch service. It's supported by our community edition. As I mentioned earlier, open sourced in Apache 2. And it allows you to easily provision new instances of Elasticsearch, scale them down again within seconds instead of minutes when you do that in real AWS. Literally, I had it yesterday. It took like 15 minutes or something to provision all the instances for the nodes and stuff. You can have that within seconds in LocalStack, and it's all on your local machine. You can just run against, and if you tear down the container, it's gone, right? So let's continue our demo, our Fluent demo, just here with another terminal. So we already have our instance running, and what we want to do is we want to create a new domain for the Elasticsearch meetup, and we get instant feedback that it is being created. So processing is still true here, which means that it's starting up, like if you would do that in Elastic in AWS. And we already have an endpoint here, and we can just. So that was the create endpoint. We now check if it's available. And now it's already provisioned. And we just take the endpoint here and curl it. And we can see we have the landing page of an Elastic instance, right? And all we have here is just one small Docker container. I'll just hide that here. So this container contains basically AWS, so to say. And that's it. You could also do that with standard tools. That's also pretty neat. So you can just use AWS and point and change the endpoint with all the AWS tools. You can set the endpoint manually and not use like, I don't know what the official endpoint of AWS is by heart, but they are baked into the CLI. You can then change that with the endpoint URL parameter of, for example, the AWS CLI. But we have some neat tools, some neat wrappers like this, like AWS Local, the one I just used here in the command. Can't really read that here, sorry. For the bad selection of colors, but you can just use AWS Local, and that's a very tiny wrapper around the official AWS CLI, which basically does nothing but changing the endpoint URL. But this makes it quite nice to use, because you can just use an alias in your script if you want to run it in LocalStack, and remove the alias if you want to run it in AWS. Yeah, and then let's jump to a real demo. And what we want to do is we want to basically implement a workflow which I just outlined a few minutes ago, where you have a Lambda which is triggered with, I don't know, a Lambda URL in this case, which creates some data, sends it to a Kinesis stream, This Kinesis stream is the source for a fire hose, and the fire hose basically has the destination Elasticsearch, which is also created in AWS. And basically what that means is that when we go to the browser, we trigger the invocation of the Lambda, the data will end up in Elasticsearch. And in the end, we're gonna take a look at it in Kibana. Yeah, and we want to do that with Terraform. We'll hear more about that, about Terraform and Elasticsearch in the next talk by Philip. And yeah, and then we'll evoke it, the data will be sent, and we'll visualize it. So let's do that. I'll just close my previous instance. Oh, by the way, if you want to try that on your own, basically in our LocalStack Terraform samples, I just created a new one, which is called Lambda Kinesis Firehose Elasticsearch. Very, yeah, I'm not very creative when it comes to naming. So yeah, you can also scan the QR code, but it's easily findable in our Terraform samples in the GitHub org. Yeah, and I'll just go to exactly that repo. So let's take a look at what we have here. Basically, I have a small Docker compose, which sums up the configuration for LocalStack here. It just uses the LocalStack image, exposes some ports, and enables debug. And this is these two configurations, like the endpoint strategy and the edge bind host, that is necessary for us to be able to access this the instance of Elasticsearch. Ah, yeah, sure. Sorry, like this. Great. Yeah, so these two configurations, the strategy and the endpoint, are just necessary for the two Docker containers to be able to connect to each other, right? Because the Elasticsearch is running within another Docker container and then Kibana, and it's not the same network now because it's just an easier setup. So yeah. And what we have here is basically we need to give it the Docker socket because that's actually not necessary for our example, but lots of our LocalStack features, actually it is necessary because the Lambda is executed by default in another Docker container. So basically LocalStack needs access to the Docker socket, and we want to cache basically downloaded infrastructure like Elasticsearch. It's downloaded on demand as soon as you use the service first, and then it downloads the version you want to start. And we don't want to do that all the time. This is why we cache it on the host, because otherwise it would be removed or not available anymore as soon as the container is recreated. Yeah, so that's basically the compose. And then we maybe look at the infrastructure provisioning, which is basically just a lot of glue and one Lambda function. So here we have some default configuration like a region, some IAM stuff. And then we have the actual function. Take a short look at the code there as well in a minute. It's just a very, very simple one where we just forward the data, but more on that in a minute. And then we expose the function with a Lambda URL. It's a fairly new feature of AWS, which is also supported in LocalStack, where you can easily get a new URL for a Lambda function without like all the API gateway stuff. Then we want to have an Elasticsearch instance. Obviously, we want the Kinesis stream where the Lambda sends the data to, and the S3 bucket and the firehose. The S3 bucket is necessary for the firehose stream, and this is basically the glue for firehose, where we set Kinesis, the Kinesis stream as a source, and the Elasticsearch as a target. And then maybe let's start with provisioning it by starting our compose. Oh, sorry, I'll do that detached mode. And then I also created a very short run script. We could also do that with just a small command, but I'm also invoking it once. So basically, here I'm using the alias again to use LocalStack or AWS local or TF local instead of the AWS CLI or the Terraform CLI. And then I like to live dangerously, so I just do a Terraform apply auto proof, which can be quite expensive if you do that against AWS. And then after the provisioning is done, I get the URL for the Lambda and the endpoint for LocalStack. And then I basically just print some info and invoke the Lambda. By using a curl against the function URL, the Lambda will actually be invoked. And that's what we're going to do now with the run script. I could actually show you other stuff in the meantime, but since it's like very fast, I actually want to like highlight that it's quite fast. This is why I'm not jumping back to the code again, because it will just take like 20 seconds or something, or maybe 30 until everything is up and running. You can see here that all the different resources are already created. The Elasticsearch instance is already up and running. And now the dependent services are or resources are provisioned. And now we have the Lambda URL. The last thing is always the Firehose stream, and then we're done. Just a few more seconds. I guess it's more than 30, but it's less than 15 minutes as it would have been on AWS. Here we go. And we already have the invocation, and we see the result here already. I don't know if you can. Yeah, I guess you probably can't read that. I'm having a hard time in increasing the size here. I need to use a different terminal. I actually would, but my overlay terminal doesn't work when I'm sharing screen for whatever reason, Linux problems. But as you can see here, the provisioning was successful, and we can see that this is the function URL. It was invoked, and now we could actually already go to create our instance of Kibana and take a look at the data. But I would like first show you what data we actually sent, because it's quite trivial. I was a bit lazy when creating the example. So I actually, this is the whole Lambda function. And as you can see here, we do a small thing to change the endpoint URL for Boto, which is the AWS client for the AWS Python SDK, basically, because this is the only thing that would have been a pro feature here. We have like Boto instrumentation in LocalStack Pro, but it's not really necessary. You get an info in your environment that you're running in LocalStack, and you can conditionally change your endpoint here. And then we create the Kinesis client and just basically dump the whole event data there, and hope everything went well, and just return a hello world, right? Yeah, so this is what we already did, because we already invoked it. Here's the URL, and we can also just quickly do that in our browser. If copying stuff would work. It works here. Let's do a curl. Oh, interesting. I just installed that terminal emulator today, so I'm sorry that I'm not very fluent with it. It was maybe not the best idea to do that on a day before a demo. But as you can see, we have the function URL here, and it returns our hello world. And in the back, before returning the hello world, it also dumped the whole data the Lambda got to Kinesis. It was forwarded to Firehose, which in turn then dumped it into our Elasticsearch instance. And now, finally, we would like to take a look at the data, and we'll do that by just creating a new instance of an Elasticsearch locally. Just prepared a Docker file here. We're using 7.10 here because the version of Elasticsearch is 7.10. And we're basically pointing it towards our endpoint of Elasticsearch, which is running in LocalStack. And should be up and running in a second. Yeah. Here we go. I'll just quickly create an index pattern here. And we can already see the 3 hits I did, like the 3 invocations of the Lambda URL. We can just do one more to ensure that this is really what we were doing, that I'm not lying here. Oh no, that now doesn't work. Sorry, I need to use a different terminal here. Here we go. We have another invocation, and here we now have a new hit. Nice. So that basically showcases that the whole round trip worked. We invoked the Lambda using a Lambda URL in LocalStack, which dumped some data to Kinesis. In turn, was delivered to Firehose, and the destination was Elasticsearch. Right. And that was basically the demo itself. We can then also destroy all of that with Terraform. But we actually don't really need that, right? Because as soon as we destroy the container, it will all be gone anyways. Okay, here we go. Now we cleaned up properly after ourselves. And yeah, I guess this was the demo. The next thing is a call for participation. That's actually the last thing I have, because we really want to hear from you, how and if you would like to use LocalStack. And maybe also if you would like to emulate your Elastic Cloud instances in LocalStack. We just created our first version of a LocalStack extension. So it's quite easy to create your own LocalStack extension, which could then basically emulate the Elastic Cloud. Would be interesting to discuss that, for example, but anything else, you can. We can just discuss everything afterwards, obviously. We're always happy if someone just drops us an issue or an email. And yeah, so thank you very much for your attention. And are there any questions? No. Oh, one. Please.
Plans to write LocalStack for Azure too?
For Azure, that's very interesting because we have that discussion nearly on a daily basis right now. We already had some tech spikes in that direction. We're really thinking about it, but yeah, it would also be quite a heavy load as well, right? So we really need to make sure that we want that. But would be happy to discuss your use case. We're nearly there to make a decision on that point.
Wasn't there a slide with Azure stuff on it?
Yeah, but that was basically stuff provided by Microsoft, right? So these are local emulators of specific services, whereas LocalStack currently only supports AWS. Please.
Are you reverse engineering the stuff AWS writes, or do you read the documentation and try to implement it yourself? Propose. So I think there's no support from Amazon.
No, there is no. We're not related to Amazon, and that's actually quite an interesting question. For the API itself, it's actually really easy because they publish API specifications, which we heavily automated. So we basically built a rapid application development framework, which just dumps the stubs, and you just have to fill the blanks, basically, if you want to implement the emulation for a service. When it comes to real internals, it's a lot reading the docs, to be honest. Yeah, you don't really see inside, right? Any other questions? No? Yeah, please.
Is it possible to run it on a cluster, so have multiple nodes with LocalStack on it and scale up with that? For on-premise AWS installation?
So that's for sure not in our terms of service, because we would definitely need to check the licensing there. For example, that would definitely not be allowed for Elasticsearch. The new Elasticsearch license doesn't allow running it on premise. Or it does allow running it on premise, but not in a service.
You cannot offer it as a service to
yeah,
third parties.
Exactly. And that would basically be the same thing, right? If we would run that somewhere, or if we would allow other people to run it somewhere and provision it for someone else, that would be obviously not allowed. So we would have to check. I've never tried, to be honest. You can run it in your Kubernetes cluster, because you can get a cluster fairly easy right now. So everyone wants to run everything in Kubernetes, and we definitely have some users which run it in Kubernetes in their company. Any other questions? No. Okay. Then thanks a lot. And I guess.
Thanks a lot.